Alright, so this is the end of the Chapter 5 review. There aren't that many problems. I think there's about 6 or 7 problems left, but they start to take a long time. So part A of 15 is just like part A of 14. I'm going to use my calculator to figure out what this area is equal to. And it's fine. I was making sure I didn't have any really bad things in here. So clear this out. I'm going to enter 12 divided by 4x minus 5 quantity cubed. Graph it between x equals negative 2 and x equal to 0. I don't have to see the graph. I don't see anything because it's off my window apparently, but I still can do the computation. Second calc, option 7, lower limit negative 2, upper limit 0. And I go, wow, negative 0.05. Rounding to 2 decimals is fine, and so I'm going to leave it there. Now I'm going to move on to 15b. 15b, I have to actually integrate this thing, so I'm going to rewrite it as the integral from negative 2 to 0 of 12 times 4x minus 5 cubed to the 5 to the negative 3 dx. When I move the 4x minus 5 up to the numerator, I change its exponent from positive to negative. And now I'm going to let u equal 4x minus 5. I need to also get rid of that 12. I'm going to do 2 steps in one here. So du dx, the derivative of 4x is 4, the derivative of minus 5 is 0. I'm going to need to get rid of a 12, so I'm going to multiply both sides by 3. And I'm going to get 3 du dx equals to 12. So for this, I'm going to put a u in, and for this, I'm going to put a 3 du dx in. And generally, when you change from x's to u's, you stop writing the numbers because these numbers are for x's and not u's. So this is going to give me the integral of 3 du dx times u to the negative 3 dx. I'm going to cancel the dx's, and that takes me to the integral of 3u to the negative 3 du. I'm going to add 1 to the exponent, divide by the new exponent. That's going to give me 3u to the negative 2 over negative 2. I don't need a plus c because I'm going to plug numbers in. And then I'm going to flip-flop like I did earlier. I'm going to move the negative sign up to the numerator. I'm going to move the u down to the denominator. And that's going to give me negative 3 over 2u squared. And I'm going to change the u to 4x minus 5. So this is going to be negative 3 over 2 times 4x minus 5 squared. And that's what I'm going to have to evaluate at negative 2 and at 0. Takes a lot of room, so I'll do it on another sheet of paper. So I need to take this negative 3 over 2 times 4x minus 5 squared and evaluate it at negative 2 and at 0 on my calculator. First one, I'm going to do negative 3 divided by 2 times 4 times 0 minus 5 squared, and then minus negative 3 over 2 times 4 times negative 2 minus 5 squared. Should be able to make both of those into fractions. Ultimately, my answer, I want it to be equal to negative 0.05, but I also want it to be a fraction. So these computations I do from my main screen. Let me try this. I think to be safe, I'm going to, in my denominator, have 2 sets of parentheses. So I'm going to enter this like this. I'm going to go negative 3 divided by bracket 2 times, or parentheses, because I can't have brackets in my calculator, 2 times parentheses 4 times 0 minus 5, probably do that with the parentheses, squared parentheses. So that's what I'm going to try to enter on my calculator. And for the next version, I'm going to enter all that same thing, but change the 0 to a negative 2. So let me see if I can do this right. So negative 3 divided by parentheses 2 parentheses 4 parentheses 0 minus 5 parentheses squared parentheses math, enter, enter. I get negative 3 over 50. And I'm going to be slick now. Oh, I guess I'm not going to be slick. I'm going to do the next one just like it. I'm going to go negative 3 divided by parentheses 2 parentheses 4 parentheses negative 2 parentheses minus 5 parentheses squared parentheses. And then math, enter, enter. Get negative 3 over 338. I'm really worried that I didn't enter that right, but. So now I have a double negative. I'm going to do this computation on my calculator. I hope to see that number. If I see that number, I'm going to math, enter, enter, and make it a fraction. So now I need to go negative 3 over 50, and then plus, because the double negative goes there, 3 divided by 338, and negative 0.0511, that's what I wanted to see. So math, enter, enter, and I'm going to write negative 216 over 4225 for my answer to part B. Let me just go ahead and make sure that, because just what I just got here is negative 0.051124. Let me just go back to my this and do second calc integrate from negative 2 to 0 is exactly that number. So I really feel good about my work because it came out to be exactly what parts A and part B came out exactly the same in terms of a decimal. So again, this was 15, part B. All right, getting closer. Ugh, so many problems, and there's really not that many. They just take so long to do, I guess. So 16A is using my calculator, and I'll try to match that answer up. And in this problem, well, let me see what I might be able to get something nice in this, but let me not say anything about what I want for an answer until I get deeper into this. So I'm just going to enter the function, make my window from 0 to 1. You can actually see the graph, I'm surprised. And now second calc, option 7, lower limit 0, upper limit 1. So 6.87 is the decimal answer that I'd like to get when I do 16B, but I might want a better answer than that, and I think I'm going to want a better answer than that. So for 16B, I need to do U substitution. I'm going to integrate that function. I'm going to start off by letting U be x squared, then du dx is going to be 2x, but I need to replace an 8x, so I have to multiply it by 4. And 4 du dx is going to equal to 8x. So now I'm going to do my two substitutions. I'm not going to write the 0 and 1 because those apply to x's and not u's. And for the 8x, I'm going to put 4 du dx. I'm going to leave the e, but in place of the exponent x squared, I'm going to put a u. I'm going to cancel, and that's going to give me the integral of 4e to the u du. And that's the nicest kind of integral because e is its own integral when its exponent is just a single letter to the first power. So this is just going to be 4e to the u, and I'm going to change that to 4e to the x squared, but I need to evaluate between 0 and 1. That I'll do in another sheet of paper, and I'll be able to get a really nice answer with an e in it that's going to be equal to, so my goal is the decimal version of my answer is going to be 6.87. My answer is going to be able to have an e in it without too much problem. So I'm going to take this and bring it onto this next sheet. So this is for 16b. So I have the function 4e to the x squared that I need to evaluate at 0 and 1. So I'm going to go 4e to the 1 squared minus 4e to the 0 squared. This is just 4e to the first, because 1 squared is 1, so that's 4e. And this is going to be 4e to the 0, and e to the 0 is 1. So this is going to be 4e minus 4 times 1, which is 4e minus 4. So my best answer for 16b would be 4e minus 4. I need to make sure that that's equal to 6.87, because that's what the area needs to be, actually 6.8731273. So second quit, clear, 4, and then second and divide to get the e, minus 4. And I get exactly that 6.87, so I know my answer's spot on. Okay. All right, 17, 18, 4 more problems to go, I believe. All right, so this is going to be a cut and paste, so the video might be a little messed up here. Problem 17, when I initially did it, I just made a mistake on my calculator, so I thought I'd fix that mistake. Problem 17, the first function should say f of x equals 1/2 x. The equal sign is nice to have there, but it's hardly that big of a deal that I didn't have it. The instructions say find the shaded area, and it says okay to use my calculator to find the areas. So I'm not going to do any work by hand in problem 17. I'm just going to kind of talk through the work on my calculator. And because I'm using my calculator, I'm probably going to have to accept a decimal answer. By hand, we sometimes can get answers that aren't decimals if the algebra kind of works out just perfectly. So in problem 17, I give you two functions. It says the function f of x equal 1/2 x is represented by the dashed line. So this is the f of x function. And it says g of x is represented by the solid line. So this is the g of x function. And what the question asks me to do is to find the shaded area. In order to find a shaded area, I have to integrate top function minus bottom function. And these functions switch. At first, the square root function is on top, but then at x equal to 4, it flips and the line function, 1/2 x, is on top. So in order to find the shaded area, I'm going to have to do two integrations. The first integration is going to go from the x-coordinate of where the graphs start, which is x equal to 0, to the x-coordinates of where the graph crosses, which is x equal to 4. And in that interval, the square root function is on top, so I'm going to have to integrate the square root of x minus the line 1/2 x. I'm going to write that as 0.5x because I'm allowing decimal answers, and that's going to be easier for me to enter. So that will give me this area. And then I'm going to have to integrate from x equal to 4 to the x-coordinate of where the shading stops, which is 7. Again, top function minus bottom function, and in this region, the top function is the line, which I'm going to write an equation of 0.5x for, minus the square root function. So I need to do two separate integrations. I'm going to do them both on my calculator. I'll go to do the integrations, I go to my graph screen. For the first one, I'm going to enter the function second square root of x minus 0.5x. It doesn't really, the whole function doesn't need to be in a parentheses because I only needed that parentheses because of the dx. So I could enter it like that. I need to make my window have x min of 0 and x max at 4. It turns out that I just did this problem and I wasn't happy with my work. Having the y min of -10 and y max of 10, I didn't see a very nice graph, and quite honestly I didn't care that whether I did or didn't see a nice graph. But if you wanted to see a better graph than produced with a standard y window, if I change the y's down to the 1s, you'll see a better picture, which I don't know, it's not important, but it's maybe nicer to see. And now I'm going to integrate with either window. As long as the x's are okay, the integration is going to come out okay. I'm going to integrate by going second calc, going down to option 7, dy dx, lower limit 0, upper limit 4. And the first area that I'm going to find, I'm going to round to 2 decimals. It has an area of 1.33 square units. For the second region, I need to flip my function around. I'm going to make it 0.5x minus second square root of x. I need my x's to go between 4 and 7. X min 4, x max 7. Sketch my graph. The beginning starts out at an x-intercept because it's where the graphs cross, and when you do the subtraction, where the graphs cross will show up as a x-intercept, but the ending limit of 7, the graphs aren't crossing there, so you don't get a x-intercept. But this is a fine graph. Now I'm going to second calc integrate from bottom limit of 4 to upper limit of 7. I'm going to round that to 2 decimals. And I get 1.236. I'm going to round that to 1.24. So I have the 2 areas that I need to add together. And the final answer, my goal is to get the shaded area, which is the sum of the 2 individual shaded areas. The answer for problem 17 is just going to be what you get when you add 1.33 square units plus 1.24 square units, which is 2.57. So for number 17, if this was a test question, I'd expect to see everything that I have written on the screen right now. Answer. Just like this. This is all you're going to have to show. You're going to have to show the individual regions that you integrated on your calculator and the results of each. And again, I'm not going to get a fraction answer because my calculator using the integration function, it just doesn't give fraction answers. But because it said it was okay to use my calculator, I'm going to accept that decimal answer. Alright, so I'm going to stop this and then insert this into the video, so there might be a little hiccup between 17 and 18. Right, so 18 is a little bit harder. So it says, first, part A, sketch a graph of the function f of x over the interval from a to b. So I'm going to, for part A, use my calculator, and I'm going to find the graph over this window, and I'm going to label the y's for that correspond to -1 and the y's that correspond to 2 by using my second calc value. So first I'm going to enter this function, x min and x max, copy more or less the best I can copy. So y equals clear 3 minus 3x squared, window -1 to 2, and then label some points here. So second calc value at -1, we're at 0. So that's the point -1, 0. And then at 2, we're at -9. And so this graph goes, something like this. And that's fine for part A. So part B, it says find any x-intercept within the interval. So I'm going to find the x-intercepts, and any x-intercept that's between -1 and 2 I need to include. Actually, -1 is going to be one of them because I already found out it's an x-intercept. Points are x-intercepts if they have a y equal to 0. So I'm going to get, my computation is going to give me -1, which I already have labeled, and another number that I don't know just yet. I find x-intercepts by taking the function and setting them equal to 0. For this one, I'd probably add 3x squared to both sides to get 3 equal to 3x squared, divide both sides by 3, get 1 equal to x squared, and then do plus or minus square root and square root. That's going to give me x equal to plus or minus 1. And so the x-intercepts, I'm just going to worry about the x values. I don't really need to worry about the y's, are -1 and 1. So this point right there needs to be thrown onto my graph. Now I'm going to have to find the area between the x-axis and the curve, and this is where I have to do the separate areas. And you can tell how wordy the problem is, that it tells you to find the x-intercepts, This is when areas beneath the x-axis I need to do separately from the areas above the x-axis. So it won't be confusing. I'll have you draw pictures, and when I ask you to draw pictures and find x-intercepts and ask you to find the area between the x-axis and the function over the interval, then you know you need to separate from negatives and positives. So to do part C, I'm going to need to do two separate integrations. So for part C, I need to integrate from -1 to 1. The top function there is the, it's only one function. I'm going to integrate the function 3 minus 3x squared dx, and that number is going to come out positive. It's going to be okay. And then I'm going to have to also integrate from 1 to 2, that same function 3 minus 3x squared dx. But that's going to give me a negative number. I need to make it positive, and technically I need absolute values the whole way through that computation, but I'm certainly not going to they're too messy. I'm just throwing them in at the end. Let me figure out what each one of these numbers should be in my answer real quickly. So for the first one, I'm going to second calc integrate from -1 to +1, and I get 4. So when I do this one, I should get 4. And then for the second one, second calc, integrate from 1 to 2, I should get -4, which I'm going to make this a +4. So this area is 4 square units, this area is 4 square units. My calculator gave me a -4, but I need to make it positive. My final answer is going to be 8 for this, but I need to show that by hand. So my goal for 18C, if I get anything other than 8 for an answer, I know I've done wrong. So let me integrate this. The integral of 3 is 3x, and then for the minus 3x squared, it's going to be minus 3x cubed over 3. I need to evaluate that from -1 to 1, but before I evaluate that, I'm going to simplify this by canceling out the 3's. And now I'm going to plug 1 in. I'm going to go 3 times 1 minus 1 cubed, and then minus 3 times -1 minus -1 cubed. This piece I can do on my calculator, but I can do this in my head. 3 times 1 is 3, 1 cubed is 1. Second piece, 3 times -1 is -3, minus 1 cubed is -1. So first parentheses comes out to 3 minus 1, which is 2. Second parentheses comes out to -3 minus a -1. Double negative turns to plus. That's -3 plus 1. That comes out to -2. So I get 2 minus -2, which is 2 plus 2, which is 4. That's spot on because that had to come out to be 4. This next one, when I do it by hand, is going to come out to -4, but I need to make it positive. So this is half of my work. I don't know if I could squeeze this work in here. I'm going to try to. So for this one, I just need, I have the same integral, so I just need to go 3x minus x cubed, evaluate it from 1 to 2. And that's going to have me do 3 times 2 minus 2 cubed, and then minus 3 times 1 minus 1 cubed. This is going to be 6 minus 8, which is a -2. This one's going to be 3 minus 1, which is a +2, and -2 minus 2 is -4. I need to absolute value that because it's under the x-axis. And that's all I need to see is that you've computed the two areas, and for my answer to 18C, I just add the areas together. First area plus second area equals the answer. First area plus the absolute value of the second area needs the answer. So walking through parts A, B, and C of this, sketching the graphs purely going to your calculator, sketching a graph, labeling the y coordinates for each of the x values, copying the graph, then you're done with part A. Part B, you find the x-intercepts by setting the function equal to 0, any x-intercept that's between the values of x that are given, you need to plot on the x-axis. Then you start drawing the areas that you need to find. Part C, you need to show me the integrals that are implied here. The first integral from -1 to 1, I could leave it as it was because it's above the x-axis. It's going to be a positive number. The second integral, there's only one function, from 1 to 2. I'm going to take the absolute value of that number because it's going to come out to a negative number. So for part C, you have to show me the shading on the graph, how the shading relates to the problem, and then you have to do the integration by hand, plug the numbers in for the x's, and you should have goal numbers for each of these. I knew that this had to be 4. I knew that this had to come out to be -4 because I did it on my calculator ahead of time. And then finish up by adding the positive number to the absolute value of the negative number, and it should be your answer. We actually have 3 problems left. So 19 and 20 are both ask the same question. So what I'm going to do 19 and 20, they want me to find the area bounded by 2 functions over a specific range of x's. So for problem 19, I'm going to need to sketch a graph, and I need to only look at the graph between x equal to 0 and x equal to 5. I'm going to graph both functions and find the area between. And I find an area between by taking the top function minus the bottom function. I'm going to graph both of these on my calculator, but one of them I don't really need my calculator for. The g function, because it doesn't have an x and just says g of x equal to 5, it's going to be a horizontal line. The x squared minus 4x function is going to be a parabola. So I'm going to pull out my calculator, and I'm going to graph x squared minus 4x for one of my functions, 5 for my other function, and I'm only going to look at it between x equal to 0 and x equal to 5. And this is kind of nice because the parabola looks something like this. So it looks to me like this is a reasonable graph. Looks like they intersect right there at 5, and during the whole window, the line is on top. So I'm going to find the shaded area here. And the nice thing is when you have 2 functions and when you're finding the shaded area, because you're doing the subtraction, you're not worried about functions dipping beneath the x-axis like when I only have 1 function and I'm trying to find a shaded area. So 19 and 20 are in some sense nicer. So that's the area that I'm trying to find. During the entire window, the line is on top, and you always integrate by taking the top function minus the bottom function. And in this window, the line is always on top. So that's what I'm going to have to integrate to get my answer. And that's going to be the integral from 0 to 5 of 5 minus x squared plus 4x dx. If it bugs you, we can write this as the integral from 0 to 5 of -1 x squared plus 4x plus 5 dx. That I'm going to do on my calculator real quickly to get a goal for an answer, and then I'm going to do all my work by hand on a separate sheet of paper. So I'm going to enter y equals clear and clear -1 x squared plus 4x plus 5 evaluated at second calc, lower limit 0, upper limit 5. My goal, this shaded area is 33.33 square units. I'm going to do this on a separate sheet of paper, and I better get that for an answer. So to finish up problem 19, I'm doing the integral of from 0 to 5 of -1 x squared plus 4x plus 5 dx. This is going to be -1 x cubed over 3. This was going to be 4x squared over 2, which I'm going to write as 2x, and the 5 integrates to 5x. I need to evaluate that at 0 and 5, so I'm going to go negative 1 times 5 cubed over 3, forgot the squared there, plus 2 times 5 squared plus 5 times 5. And then it's going to be minus negative 1 times 0 cubed over 3 plus 2 times 0 squared plus 5 times 0. The second piece is going to come out to 0. I could do that in my head, but I'll do them both by hand. And this one better come out to 33.33 because that's the final answer I'm shooting for. So, second quit, clear, negative 1 times 5 cubed divided by 3 plus 2 times 5 squared plus 5 times 5. Beautiful. Math enter that. Get 100 over 3. Next one, negative 1 times 0 cubed over 3 plus 2 times 0 squared plus 5 times 0. And that one comes out to be 0. So my answer is going to be 100 over 3 minus 0. And those, obviously, when you subtract by 0, you just get what you started with. So it's going to be 100 over 3. And we know that 100 over 3 is 33.333. And that was my goal as an answer. So I did this spot on perfectly. All right. So 2 more problems. 20. I'm going to graph f of x equal to x squared and f of x equals the square root of x over 0 to 1. The y's are so small, I'm going to change my y's to like 0 and 2 just to get a good graph of this. So I'm going to start off. Part A said to sketch a graph, or I said first sketch a graph. So between 0 and 1, I'm going to sketch a graph. And my y's, I'm going to make between 0 and 2 because I know ahead of time what these graphs look like. If you did this by hand and left the negative 10 to 10s, you'd start to see the problem we're going to have. So I'm going to just do the parabola first. I'm going to change my window from 0 to 1. And for the y's, I'm going to change it to 0 to 2. And I'm going to get a parabola that looks like that, more or less. Maybe that's not the best graph, but it's good enough. And now I'm going to graph the square root on there. So y equals second square root of x. I'm going to graph it. And it's really nice. The whole time, the square root is the top function. So the square, I drew them separately so you could tell which one was bottom and which one was top. And this whole time, the square root is the top function. So if I look at the instructions to this, it just says determine the area, and I have to sketch the area first to determine the area. So this is the area that I'm looking for, and I have to know the top and the bottom function. The top function is the square root of x. The bottom function is the x squared. So I always do top function minus bottom function over the window. Let me get an answer for this by entering this as a y1 and integrating between 0 and 1. So y equals clear, clear. I'm going to enter that on my calculator. So second square root of x minus x squared. Graph it. Second calc. Lower limit 0, upper limit 1, and I get an area of 0.333. So my goal is to get something equivalent to that for an answer. How do I do it? I have to integrate it. So I need to write the square root of x with the fraction exponent. Now I'm going to integrate by adding 1 to the exponent. So the x to the 1/2, I'm going to add 2 halves and get x to the 3 halves. And instead of dividing by 3/2, I'm going to multiply by 2/3. For the x squared, I'm going to add 1 to the exponent, divide by the new exponent, and I need to evaluate these at 0 and 1. I'm going to go to my next sheet and make that radical for the first term. So I'm going to make this 2/3 times the second root of x cubed minus x cubed over 3. I'm evaluating it at 0 and 1. So this is going to be 2/3 times the square root of 1 cubed minus 1 cubed over 3 for the first half. And then minus 2/3 times the square root of 0 cubed minus 0 cubed over 3. The second piece again is probably going to come out to 0. The first piece better come out to be 0.33. Otherwise I've messed up. And 0.33 is probably going to be 1/3. So first piece, back to the main screen. Clear. 2 divided by 3 times second square root of 1 cubed minus 1 cubed divided by 3. Math, enter, enter. This one comes out to 1/3. Second piece, 2 divided by 3 times second square root of 0 cubed minus 0 up arrow cubed divided by 3, and you get a 0. So you get 1/3 minus 0. That's clearly 0. Or clearly 1/3, should I say. And the decimal equivalent of 1/3 is 0.333, and that's what my calculator told me the area should be. So I feel good that I've matched up my answer for number 20 to what my drawing tells me it should be. Alright, last problem. So it gives me two functions, and it asks me to find where the graphs intersect and then find the area between where they intersect. So I'm going to have to, in a more standard window, graph x squared plus 3x and 5 minus x. Heck, I can get my window set up pretty quickly here, can't I? Yeah, let me do some algebra first. How do I find where they intersect? I set the functions equal to each other. So to do this, find the 2 points where the graphs intersect. I need to set the equations equal to each other. For this one, I have to set it equal to 0 by minusing 5 and adding x to both sides. That's going to give me x squared plus 4x minus 5 equal to 0. That gives me x plus 5 times x minus 1 equal to 0. That gives me x equal to negative 5 and x equal to 1. So I'm going to graph both functions. I'm going to restrict my window between negative 5 and 1. And one of them, this is a line. This is a parabola. So it's going to be easy to tell which is on top and which is on the bottom. Because ultimately, one's going to be on top, one's going to be on the bottom. Let me do this real quickly on my calculator. So y equals x squared plus 3x, and then 5 minus x, and then window negative 5 to 1. I'm going to make my y's back to the negative 10 to 10 because I don't think the window that we had picked is going to be good. Well, that's actually a smashingly good window. So the graph looks something like this. Yeah. The important thing is during this entire window, the line is on top. So when I go to find this area, I'm going to have to integrate between negative 5 and positive 1 the line 5 minus x minus the parabola x squared plus 3x, like that. I'm going to simplify that. So this is going to be the integral from negative 5 to 1 of 5 minus x squared minus 3x dx, and combine the minus 1x and minus 3x. So that's going to be the integral from minus 5 to 1. The integral from minus 5 to 1 of negative 1x squared. Those combine to be a minus 4x plus 5. Let me do this on my calculator to make sure the answer that I get by hand is fine. So clear, negative 1x squared minus 4x plus 5. Graph it. Second calc, integrate it, starting at negative 5, ending at 1. And the area that I initially shaded is beautiful. It has an area of 36. So I'm going to do all this on a separate sheet of paper and try to get 36 because that is the area that's described by that. So now we start with the integral from negative 5 to positive 1 of negative 1x squared minus 4x plus 5 dx. This first piece you get negative 1x cubed over 3. The second piece you get minus 4x squared over 2, which is going to be minus 2x squared. The last piece I'm going to get a 5x. I have to evaluate them at both negative 5 and 1. So I'm going to go negative 1 times 1 cubed over 3 minus 2 times 1 squared plus 5 times 1, and then minus negative 1 times negative 5 cubed over 3 minus 2 times negative 5 squared plus 5 times negative 5. Hopefully these two things combine together to be 36. So off to my main screen. Second quit. Clear. Negative 1 times 1 up arrow 3 divided by 3 minus 2 times 1 squared plus 5 times 1, and I get math, enter, 8 over 3. Next one, minus 1 times minus 5 up arrow 3 divided by 3 minus 2 times minus 5 squared plus 5 times minus 5. Math, enter, negative 100 over 3. The double negative I'm going to make plus, so I'm going to go 8 divided by 3 plus 100 divided by 3. I get lovely 36. That's exactly what it had to be. If it came out to be anything other than 36, I would have really worried. So my answer to number 21 is just 36. Again, if you did all the work on your calculator and didn't show anything by hand, you're going to lose a lot of points. So make sure that you're doing all the by hand work that you have to show to get your maximum credit. Alright, so those 21 problems will make up the entire test, and I guess the test has to be a bit shorter than that because it took me, closer to 2 hours to finish that, and you only get an hour to do the test. So come visit me if you're stuck on anything.